So virtual memory will be our topic of the day, and today we will be discussing about what is virtual memory in an operating system and what does it exactly mean. So first of all, question: how much RAM does your system have? You would be most of your answers would be in somewhere around 4 GB, like that's too less, or 8 GB, or 12 GB or something, etc. But as for your information, virtual memory, this concept, you know, when you have a program running, this concept makes the program feel that the RAM that you have is far more than your existing RAM on the system. For example, the system might perceive having 1 TB of virtual memory. It's not the system, sorry. The program might perceive that it has a 1 TB of memory or even more. Now, why is this? Because when you have a program, a C program written, you know, that thing in the memory that is divided into pages. You have pages. Mostly a page size is generally 4 KB, but it can vary. So program is divided into pages, and RAM is not always supposed to have all the pages readily available. It is supposed to have only specific things, the requirements, the needs of the program during the execution or something. So when the operating system needs a page, it accesses the disk and puts it in the RAM. So it's easier to access, and the latency decreases, and you don't need more time and more CPU cycles to access that page. But the thing is, when the RAM gets full, there would come a time when your 4 GB or 8 GB RAM would be full. At the time, what do you do now? So when now the program which was running, that would need some other page which is not in RAM. So it would generate a page fault. When you need a page that is not in RAM. Now, what does a page fault do? A page fault makes the OS access the disk and put the particular page that we required in the RAM. And we need to swap one of the existing pages that is already in the RAM because we have a RAM full. We need some space there, so we would first need to make it. So we would swap a page with the page that we need. Now, how does the OS choose that which page among the entire RAM it needs to swap with? Because since you have an 8 GB RAM and a 4 KB page size, you would be having a huge number of pages, 1024 roughly pages. Like, how are you supposed to know like which page I need to swap? So there are many methods. For example, one of this is LRU, which is last recently used. I'll explain that in detail in one of the upcoming videos, but it picks up the page which is at the last in the queue of recently used pages, and it replaces it with that because it's more likely to be not needed in the future. So this is one of the strategies that we have. So this is the concept of virtual memory, that your program feels that it has more memory than RAM. Like, technically, given the program size, it appears like it has infinite memory, especially if the RAM is bigger. So it gives an illusion of an infinite memory. So that is what virtual memory is all about. In the upcoming videos, we will be looking at what exactly are pages, what is a page table, what is a global page table, and what is a TLB buffer, and how you can make a loader using this virtual memory information that you have just read, that the generation of a page fault and demand paging. So that's all for this video. See you in the next video. Till then, bye bye.